You all are able to see my screen. So I welcome you all to this session on introduction to data structures. So data structures, when you define, is basically is way to organize the inside a computer's memory so that the major important operations on the data, especially searching, sorting, inserting, deleting, can be done very efficiently. So the main purpose of studying data structure is what are the different ways in which you can organize your data so that the data can be sorted, searched, and also any insertion deletion on the data can be done most efficiently. Okay, so there are some important reasons why you should be studying data structures. If you look at some of these points, if you look at some of these points here, it will pave the way for organizing data in a systematic manner. So computer allows you to store data in any way you like, but there should be a systematic way of organizing the data. So you will explore what are the different ways you can organize data, and the choice of particular data structure, okay, significantly impacts the efficiency of algorithms. So you might have studied a lot many algorithms during your undergrad, maybe searching algorithms, sorting algorithms, or traversing a path in the efficient way, and also finding the efficient combination of objects to maximize the profit and all. So in all these algorithms, use of a particular data structure will significantly impact the performance of these algorithms. So from that perspective also, studying data structure is very important. And data structures allows you to define data structure in a very abstract manner. It means you define what are the data items you are storing and what are the operations you are performing in a very abstract way, so that the implementation can be done in very different ways. So as part of data structure study, we shall see what these ADTs are. ADT stands for abstract data types, and this particular subject helps you to explore several different ways in which you can organize data, and also look at how this organization of data is suitable for different application scenarios. What is suitable in one application scenario may not be very much useful. Okay, so you have to look at which type of organization helps in which application scenario. So all these together will help you understand what data structures really are and why it is very important to study them. Okay. Now before we look on to the details of the data structure, let's understand the big picture of what all data structures are there and how they are classified. So basically, data structure is classified broadly as linear and non-linear. In linear data structures, the data items can be identified if you know the position of one element. So they normally are linear in nature. For example, arrays. If you know index of one element, you know index of where the next element is stored. Similarly, linked list, if you know the address of one node, you know where the next node is. Likewise, queue and stack. So all these four fall under the category of linear data structure. Then in non-linear data structure, we have trees and graphs. The reason why they are non-linear is that if you know the address of one node, you cannot directly know the address of other nodes. Okay, though they are linked, but linked in a very non-linear fashion. All right. So that is the second category of data structure. And then there is the other type of data structure that include heap and hash table. So these are very special in their nature. All the while we are discussing, like, we store data on heap. Okay, what this heap is really, how it is made up, and what operations we can perform, we shall see as part of data structure. And also there is one very important data structure called a hash table. So this is the most efficient data structure ever. It will allow you to do the searching very fast. So we can begin data structure with simplistic way, in a very simple way, starting with arrays. We already studied arrays, right? So array is a contiguous collection of data where one element follows the other, and each element can be accessed through its index. Okay, so elements are accessible through their indices. As you can see, element 3 is accessible through index 2 and element 7 is accessible index 3 and like that. So basically, if you look at any data structure, you will see two things. One is data structure is a collection of data objects. These data objects can be of type integer, strings, float, double, etc. And also every data structure will have a set of operations on them. So these operations normally fall into two categories: accessing the elements and also modifying the elements. Now, when we study data structure, as I told you, data structure have significant impact on the algorithmic performance. So we need to look at what algorithms are and how efficiency is computed given an algorithm. So I guess in your undergrad you have studied big O notation. Are you familiar with this concept of big O notation and all? No?
Little bit
Little bit. Okay. So maybe
partial.
you might have forgotten by now. Okay. So let's understand this, because whenever we talk about data structure, I will always talk in terms of what is the algorithmic performance or what is the time complexity of the algorithm when that particular data structure is used. Okay, so we define the algorithmic complexity in terms of time complexity. In fact, there are two: time complexity and space complexity. We don't bother much about space complexity because today memory is very cheap. We only worry about how much less time it can take. So we only look at time complexity. Now there are many ways of measuring the time complexity of algorithm. So one which is adopted worldwide is this big O notation. Now, what is this big O notation? Normally, if you write any algorithm and you translate into a program, you can actually on a computer you can compute how much time is taking. But the problem is, if you move from this machine to another machine which is slower, the times would differ. So we want a particular framework using which the computation which I do, the time complexity, it should be independent of the machine. So that is where the time complexity in terms of size of the problem will come. So as you can see here, we define time complexity as a function of n, where n is the size of the problem. For example, in a sorting, you want to sort n elements. So n is the size of the problem. As you can see, as n increases, the time taken will increase. Okay. But in what form, in what manner the time increases depends on the kind of algorithm that you are making use and also the data structure you are adopting. Now, basically, an algorithm will begin like this: algorithm, name of the algorithm, okay, and every algorithm will have a set of arguments here. As you can see, there are three arguments. One is the array, second is the key that you are searching, and third is the size of the array. Now within this you are doing a for loop here, and if ai equal to key, it means if you have found the element, you return the index of the element. Otherwise, when you come out of the loop, return -1, indicating that the element is not found. Now how do I compute the time complexity of search item algorithm? Okay, so that can be done to evaluate the algorithm complexities. Find out what is called as basic operation. Now every algorithm will have one or more basic operations. We have to identify this. So basically, basic operation is the one which occurs within the innermost loop of a algorithm. So as you can see, there is only one loop here. There is only one loop, for loop. So within this there is a operation. As you can see, this is a comparison operator. This is a comparison operation. So we need to find out how many comparisons are taking place, and this comparison is more significant than everything else in the program, and we need to estimate how much is the time taken. So that is what is the time complexity. So what we need to do is find out f of n. In this case, as you can see, total number of comparisons, if you find running the loop, I will start from 0 and goes up to n minus 1, and every time it goes through the loop, it is doing one comparison, isn't it? So you will have a total of n comparisons. But the problem with this approach is if the element is first element, then you will have only one comparison, right? And if the element is at the end, there will be n comparisons. So how do I find the computing time in this case? So we employ what is called as average computing time. Analyze this is find average computing time. Now how do I arrive at this? If you see the loop, if the element is first element, you will be doing one comparison, right? And if the element is at position 2, you will be doing two comparisons because you are going sequentially. If the key that you are searching at position 3, you will be doing three comparisons like this. And if it is at the end, you will be doing n comparisons. You will be doing n comparisons. So total number of comparisons, this is the arithmetic series, you have a formula like this. So these are the total number of comparison if you search all the elements. But normally you'll be searching only one element, right? So what is the time taken to search only one element? It is the total time divided by number of elements. So total time we know it is n into n plus 1 by 2 and divided n into n by 2 and divided by this n. This n cancels. What you get is n plus 1 by 2. And if n is large, you can approximate it to computing time f of n will be approximated to n by 2. Okay. So on an average, you will be comparing 50% of the element. That is what is the meaning of this. Now, whenever you do such analysis, okay, you will end up with some function f of n. And this function is very simple in this case. It is just n by 2. So if there is another algorithm which is taking n by 3, you know that is going to take less time than this. It is easy to compare. But normally what happens, this f of n tends to be a complex function. For instance, if your algorithm is taking some computing time, if you end up some equation like this, like 2n square minus n plus 2, something like this. Okay, so this is a polynomial in n. In that, if you plot f of n, it will go something like this. As n increases, the f of n will also increase. Now, this function f of n may be a complex polynomial or may contain logarithmic terms or even other terms also, exponential terms. So we want to find out a simpler function g of n, okay, which when you multiply with constant c, it will always be above this. Okay, so this is what is cgn. Then we say f of n will be bounded by cgn. That is, this will always be less than or equal to this. It means if you observe these two graphs, cgn, where c is some constant, I can choose c as anything, half or maybe 100 or whatever, some c you have to choose. And this c can be minimal value which will keep this cgn above fn. Okay, so the meaning of this will be clear if I take an example. Let us say bubble sort has computing time of n square minus n divided by 2. Okay, now if you see this, n square minus n by 2 is slightly more complicated. If I expand this, it is n square by 2 minus n by 2. But instead of using this whole thing, if I assume g of n to be just n square, okay, and take c as half, you will see that cgn will be n square by 2 because c is half. And since you have dropped this term, f of n will be always less than equal to this n square by 2. Okay, so big O notation allows you to use a simpler function. So you can say, even though expression is n square minus n by 2, you can assume that computing time to be just big O of n square. It's difficult to understand initially, but as you get acquainted with this notation with other functions, you will get to know that any function which is simpler than f of n and which stays above f of n is called as big O of f of n. Okay, so big O notation is nothing but finding a simpler function gn which when you multiply with some constant c, like in this case half, it will stay above fn. Okay, and this is a simpler expression to compare with other algorithms. Okay, so if you look at the definition of big O notation here, any function fn which is coming from the algorithmic complexity, it is possible to find a simpler function gn such that f of n will be always less than or equal to g of n. Okay, so in the notation I should be using less than or equal to. Now we'll see through many examples what is this big O notation and how it applies. And you will see that this big O notation becomes important beyond certain n naught value. Below this you don't bother much because for small values you don't compare the algorithms. We want to compare the algorithms only when n becomes very very large. It is like, five people are on a running race, and if they have to run only, let's say, 100 meters, all will run equally fast, right? But if I set up the length as 100 kilometers or 10 kilometers, then you know who is performing well, isn't it? So algorithm complexity has to be computed as n becomes infinity. This is also called as asymptotic notation. Okay, so any polynomial that is there, f of n, can be replaced by another function g of n, which when you multiply with c will always stay above this with this equation, and this is denoted as big O of g of n. So if you take this example, your g of n is just n square, so bubble sort is bounded by big O of n square. So that is why in our notations we say bubble sort computing time is big O of n square. Okay. Yeah. Now there are different big O classes. Okay, these are called as algorithm classes. For example, if the algorithm takes fixed amount of time, then we say it is called as constant class, where f of n is 1. And if the algorithm is taking n comparisons, we call that algorithm class as linear. And if the algorithm takes n square time, like your bubble sort or insertion sort or even selection sort, all these fall into category of quadratic. Okay. Then cubic, if you take matrix multiplication, then it falls into category of cubic. Okay. Then any algorithm which has a log term like log n or n log n, these are called as logarithmic class of algorithms. Certain other algorithms take a to the power
Excuse
n.
me,
Yeah.
sir. Actually, for matrix multiplication, it is n cube. I think because we use two for loops, right? I think it is cube
No, no,
for f
no.
of n,
It will be 3 for loops.
three for loops.
For addition, it is 2 for loops.
Okay.
Because every row has to be multiplied with every column.
Right, and
So,
again you have to
yeah.
do
So,
m cross n plus n cross m kind of thing,
yeah,
right?
n
Yeah.
cross n kind of a thing, it will result into n cube. Okay.
Okay. Okay.
Yeah.
Right.
And there is exponential time algorithms also. For example, if you say Tower of Hanoi, you might have come across this problem, right? Tower of Hanoi, we have three poles in which there are three disks, and if you want to move these three disks from A to C using B, then you have to indicate in what different ways you can move them following certain rules, like the bigger disk should not come under the smaller disk. So that is called as Tower of Hanoi problem. So there, if there are n disks, it will take 2 to the power n. So here the time complexity quickly increases because of the nature of exponential nature of that algorithm. Similarly, some algorithms may take factorial time, like traveling salesperson problem. Okay, so these are the various categories of algorithm complexities we should be aware of. Okay, so essentially what you need to understand is that data structure is way to organize data in memory for efficient storage and access. And data structures have significant impact on the algorithm time complexity, and time complexity measured in terms of size of the problem, and big O notation is very very popular. There are other notation, omega notation, theta notation. You need not worry about them. They are on similar lines, but most of the time we'll be using big O notation. Okay, so is this concept clear of what big O notation is? Some doubts?
Yes, sir.
Okay, you might have picked up in a very minimalistic way. That's fine. Subsequently, when we discuss all the other data structures, we'll be using these notations, and if there is any difficulty, we'll address them accordingly. Okay. Now, having learnt the overview of what data structures are, different categories of data structures, let us see a very simplistic way in which a data structure can be implemented. So let's say I'll take array. As I told you, array is a data structure. Okay. Now, how do I justify that array is a data structure? Now, array allows you to store data of different types. I have taken the example of an integer array here, and I'll define a class array list. So this array list is my data structure, and data structure will contain data objects plus a set of operations on them. So what are the different operations I can think of? First thing is, if the elements are stored, then I can find the index of the element where it is stored given the element itself. Second is, given a new element, I can store it, okay, at the end of the list. Then delete a value which you pass, if it exists. Then you can insert an element after certain position, where x is the position of the element in the array, and also display all the elements. So when you define any data structure, you are free to define your own functions here or operations on them. It is not limited by anything, but only as per the requirement of the application. In most applications, you want to store all the values, you want to search for the element, you want to delete some element, and then you want to insert somewhere in between, and you also see what all elements are stored. Okay, so having declared a data structure, like, as you can see it now, it is in a very abstract form. We have not told you how we are going to implement them, so the implementation part can follow here. So what you have to do is, you have to go on implementing one by one. For example, I want to implement the first one. So I use the scope resolution operator here. Find index, which takes the element x. You want to simply return the index of the element. Okay, so how do I do that? So I can set up the loop for int I equal to 0, I less than count. Now this count is initialized to 0. Initially there are no elements. As you add elements, count will get incremented. That is what we have to do in the store value and insert after. These are the two operations which will help you store the elements. Assuming that there are already certain elements, I can perform where the index element x is stored in the array. So I will set up the loop. In the loop, what I do is, if x is equal to, as you can see, the array name is a and index is I. If the element is found, you return I here. And when you come out of the loop, you have not found anything, so you just say return -1. Okay, so in a very simplistic way, I can define find index of the element x that is passed to this function. So this is the first operation that I can perform. Likewise, I can perform other operations like store value, void array list, store value x. So when you want to store this value, initially there are no elements in the array. Okay, so all that you have to do is, you just have to say a count plus plus is equal to x. isn't it? Assuming that there is enough space. So I have already declared max size as 10. In fact, you should check whether there is enough space or not. You can put a if statement here. If count less than max size, then you do this. Otherwise, you say else cout array list is full. Isn't it? So this is the logic that is required to define the store value operation, isn't it? So the next operation that I want to perform is delete value. Why delete? Sorry. The operation delete and delete value. Again, I should use group resolution operator here. Delete value int x. Now, how do I perform this delete operation? Okay. So what you have to do is first find out where that element is. So you say int j is equal to, you already implemented find index, isn't it? So this will return you the position where the element x is stored. Now deleting is simply shifting the remaining elements backward. So you can set up one more loop for int I equal to j. I less than count I plus plus and a of I is equal to a of I plus 1. So next element has to be shifted backward. See, you have element 6, 7, 8, 9, something like this. You want to delete 7. So what will you do? You locate where 7 is and then copy 8 in its place, and in place of 8 which was here, sorry, in place of 8 which was here, you copy 9 and that 7 is deleted, and before you return you should decrement the count by 1. So count minus minus. So this will implement deletion of the element in the array. Okay, so finally after this, insert after. Suppose if you want to insert the element after array list, insert after. Now let's see what are the arguments we are expecting. So we are expecting an element x. This is the position of the element. If you want to rename it as position, that is fine. And this is a new element or item. Now let me change this a little bit. Instead of x, let us say this is the position after which you want to insert. So what you should do here, you have to shift the elements. Suppose if you want to insert after 8, so the position of 8 is given to you. What should happen is after this you have to store the element, and you first have to shift the element starting from position plus 1. So for int I is equal to position plus 1, I less than count I plus plus. So here I have to say array of I is equal to,
But before that, do we need to find out like whether the particular array is maximum or not? Meaning the size of the array is
no, size of the array is in count, no.
right, but actually
Yeah,
we want to
yeah.
max.
So that check we have to do.
Yes.
So the way to shift this to the right is I plus 1 is equal to a of I. Am I right? Just check.
10. I think we need to take temp and we need to insert a type one and then we need to increment
See,
everything.
position 1, you are here and you are
Right.
shifting this to this position. So I plus 1 will be, and after inserting you have to increment the count by 1 because you have inserted. But this logic, let me check 1 minute, slightly complicated here. Insert after is, yeah, this I equal to j plus 1, I plus 1 ai, I plus 1 ai, that is correct. Okay, so we'll see the uh, execution and see if it works fine for us. Only thing is we should see that after before inserting whether count is way less than the max size.
But we have to insert the new item at EF5 plus 1. We have incremented, but we have
Oh,
EF5
yeah,
plus
yeah.
1
One more step is required here. So at a position
of I.
plus, you have to insert this new item. That's right, isn't it? He has given the position after which you have to insert. So you have made room for that using this for loop and you are inserting this item and you are incrementing the count by 1. Okay. So all that remains now is just display the elements. So we have to say void array list display. Since you want to display all the elements, you can okay, because we will be having less than the max size, so we have to go with this only, I less than count I plus plus C out A of I and a little bit of space. Okay, so we defined array list data structure with two data objects here. One is the array, second is the count, as to how many elements are there. In the constructor of this class, we are initializing count to 0. So initially there are 0 elements. So we will be putting the elements one by one, and as the elements are added, you will get different list values. So the way to define that is, let us say array list, my list, and in the my list, first thing I will store something, store value 7, my list, store value, let's say 9, store value 3, like this. Now if I say my list dot display, it should show me all the values that are stored 7, 9, 3 as an output. Let's see. Okay, so I need to remove those numbers which I have typed here. Okay, so we have 793 like this. Now suppose if I want to insert after 9 some element, so my list dot insert after, so insert after the position of 9 is 0 1, so I say 1 here, and I want to insert, let's say 11. Okay, and then again my list dot display. So the new list should contain 11 as part of it. Now here I am inserting three values, 5, 7 and 3, and I want to insert 11 after 7. So let me run this program and see. There is some issue in my program. Okay, so initially list was 5, 7, 3 and I am able to insert after 7. Okay, so this is one operation which you could do. Now suppose if I want to delete something, items dot delete value. So I can specify any value here. Let's say I want to delete 7 from here, and then items dot display. It should display 5 11 3 after this. So let's see whether that is happening. Okay, so you are able to store the elements, you are able to insert the element, you are able to display the element, you are able to delete the element. So all the operations are possible using the data structure array list. Okay, now this array list which I have implemented here, you can make it more generic. Now it is supporting only integer values. So if you want to make it more generic, we have already learned templates. So convert this class into a template class. Instead of using int a of max size, you have to use the generic type t. Okay, so do you recollect how we were declaring the template class?
Template
Okay,
uh, within the angular brackets. Yeah,
type name, right?
yeah.
T.
Type name and t.
Yeah,
Yeah,
and here it should be t,
t.
isn't it? And
Yes,
count is integer only.
right.
Okay, now if whenever you are finding index of an element, this element has to be of type t,
Type
isn't
t.
it? Then whenever you are storing the value, this is also type t,
This also type t.
right? And then when you want to display, this doesn't require any change. Then delete an item, this is of type t.
Also type t.
Okay, and what else? Insert
And
after.
there int
This
okay,
also
j is
should
equal
be
to index. Yeah,
t,
int
and this
only
also should be t,
type. And t new item.
new item. Isn't it? And now here in the array list you have to pass. If you say int, it will work as before. Okay, and if you pass strings, then it should work fine. Okay, and if you are storing strings, then you have to make it string, and these values appropriately have to change. Let us say Ajay, then now we will have to see whether it works fine, because uh, we have to do some specialization or not if you are comparing or anything. Similarly, if you want to insert after, do you think it will work or you need some modifications?
I think string comparison is required.
String comparison is required here when you are doing equal to somewhere. Uh, Here this should be string compare, right?
Yeah. STRCMP of
Comma x equal to 0, right? So those are the changes which are required. Let's see if it came up with lot many errors. String compare not declared because we have not included the library. Any of you remember which library file to include?
C string.
C stringer. I think so. It is C string. I mean, what you need to understand is we can generalize and make it a abstract data type so that any data object can be stored and manipulated. So now that we have made it as a template, it should work for data of any type. So data structure should be independent of the data type that you are mentioning. So still it's giving the problem. So in the string comparison only we have problem. So suppose if I remove this comment of this in delete value, and we are comparing, right? No, where is it? Find
Insert of
find index. Okay. Okay, if I just do this, let us see whether it is able to.
insert after, I think there is
Yeah,
one error.
yeah. So let's see if it is able to store in the first place. Yeah, it is able to store. Okay. Now only problem is that insert after and delete value is not working. This is not working. So we have to see insert after, how to rectify that. Insert after should be working. Let me check. No, it's going to that find function. No, so in the find function we have an issue here. Okay, this it is saying it is of type
A is not
A
found.
is not. So can I do like this? Compare the strings directly. Should work, no? Because X is string and A is also string.
Actually, it is pointing A is only not
Because A is of type string, no?
right.
Should work this time. Yeah. Because now it is an array of strings, so it's working fine. So we are able to insert after Vijay a new object. I think so. This delete will also work now. Let's see if it does. Okay. So my intention was to show you how we can design a data structure of your own, which is very generic in nature and has the important operations defined on the data objects. Of course, lot of work has to be done to check the boundary cases. While we are inserting, we are not checking whether we are exceeding the max size. Okay, so all that check has to be done within the methods that you have declared. Okay, so the essential thing is here array list is a data structure. It allows you to store me strings, integer, float, whatever, and allows me to perform some operations like this: insert after, delete the value that is specified, and also display all the elements like this. Okay, so this is the in its simplest form what data structure is. All right. So what you do today is whatever I have done. Okay, using an array defined these operations, you try to implement and see for yourself how the data structure actually can be implemented. And in our subsequent classes, we shall see how stack is implemented, how the list is implemented, how double linked list is implemented. Okay, we will use C++ syntax only, so that the implementation logic is very easy. Okay, so did you follow what we have discussed today, or you still have some questions?
So maybe after we execute this, we'll
Okay,
understand
maybe
better.
after you execute this, you will get to know something. Okay, so I'll share the source code with you. Just try to do it without seeing, and if you are stuck somewhere, refer to this code and uh, learn how we can build your own data structure. All right. Okay, then we'll close for today.